When it's Hello and welcome to the SFSCon. I am Fani Partsofilidou from Free Software Foundation Europe. We are excited to welcome you to the first hybrid SFSCon. Since this is hybrid, I would like for you to have some things in mind for today. For those in the audience, so for all of you here, thanks for joining us. We will be offering some questions. So the speaker might give some time for you to ask some questions. In this case, I would like you to step forward to this mic over here so that our friends that join us online can also hear your questions. And for those who are joining us online, please make sure that you ask your question as fast as possible so that it can reach actually our speaker. The following presentation will introduce you to the sustainability track. How can our increasingly digital society become more sustainable? And what policies does it take to achieve this? With this, I hand over the floor to my dear colleague and program manager of SFE, Eric Albers.
Yeah, thank you very much for the introduction. I'm happy to start the sustainability track. I think it's the first sustainability track at the SFSCon. And we have a lot of interesting talks today, and I will start with a more broad overview. So the speakers will go more in depth. I will start with a broad overview about what we need for a more sustainable digital society. And let's start with the software. So I think many of us are aware that when we run software, that we need energy to run the software. But actually, we also need already energy to beforehand, so to produce the software, to write the software. At least before Corona, for example, you are driving to the office and we turn on the light, we have a climatization, we spend a lot of woman hours in coding the project, and of course, a lot of brain power. And so there's a lot of energy invested already, but unfortunately, very often not for a long time. So this is a famous Google cemetery. It shows all the projects Google is not developing anymore and has a total death count since 2006 is more than 160, so there's more than 10 a year. And the average lifespan of a Google product seems to be 4 years and 1 month. This is not a lot regarding or thinking that how much energy has been invested to produce that software. So it would be a way more sustainable if I could reuse that software, if I could just take one of these projects and develop them further. This is what free software does allow us. There's a lot of experts here in the room. I don't think I have to explain what is free software. Just to be sure, when I say free software, then I mean software that is licensed under under a license that gives us the 4 freedoms to use, study, share, and improve the software. So the point I want to make is these 4 freedoms have a lot of benefits, but they also allow us to reuse software and basically have kind of a circular use of software where we develop software, and even if we stop it, we can reuse it and develop it further and stop it again, and so have like this wheel going of a circular use of software, which is important if you think about how much energy is invested just in producing the software. And so how much sustainable it is to reuse it. Also, reuse optimizes efficiency over time, seems to be. So here's the famous Linux kernel. It's used in the 500 top supercomputers in the world. It's used on the most servers in the internet. It's also used on old hardware, so it's very dynamic. It seems to be very efficient. So it seems also reuse has a very positive benefit on the efficiency of the software, which is also, again, very important because in the beginning I said software also needs energy to run, so a more efficient software is also good in that regard. And it's especially important, this reuse things like reusing the software and also have efficient software. If we think about what will happen in this decade, we will see an exponential growth of devices and of software that we need to run these devices, and of the energy that we need to run these devices, in particular in these fields, artificial intelligence, the Internet of Things, or let's say connected devices, and smart everything, smart cities, smart homes, smart agriculture. In all these fields, we will see exponential growth. And so let's reuse the software. So we can save more resources in the production and in the efficiency. So picking up the campaign from the Free Software Foundation Europe, this is the first point I want to make. Let's start a circular use and reuse of software. I mean, of course, it would be beneficial if like all software would be free software, but let's be realistic and start with one step after the other. It's very natural to say public money, whenever public money is invested, it should be public code. And we will see a lot of public infrastructure will be set up in this decade, so this should be with free software and public code. Did you know that free software can save lives? Don't know what you are thinking about, but at least it can save lives of hardware. This is very important because the biggest footprint occurs during the production of hardware and not during its lifetime. And if we would use our devices just 1 year longer, then we could save hundreds of millions of devices from being wasted or produced. Like when I was a child, there was this joke about a guy who owns a Porsche, the car, Porsche, and he buys a new one when the ashtray is full. That seems very absurd, but actually that is happening with our devices currently. So we buy a new device when the battery is not working properly anymore or the screen is broken. And even more absurd, we buy a new device because we don't get update of the software anymore. That is a big problem. That is called software obsolescence. So this is how I would expect like a natural, sustainable digital society. I buy a device today that comes with the operating system version X. There's a follow-up version, X+1. I install that on my device, and the circle goes on. However, that is not, in practice, not the case. Normally, I buy this device today with the version X. Then the manufacturer says, okay, has no interest anymore in supporting that device, declares the end of support, and that basically leads to the end of hardware, because now, as a user, I'm faced with the dilemma: either I run my old software and have a security issue, or I have to buy a new phone just in order to run the new software. So this problem is called software obsolescence, because the hardware is devalued by software. Fortunately, free software can help us with this. So these examples here are all, as you see, with in the Android system. This is also because it's very obvious in the Android system, the problem, also the solution, but this is also true for other environments. So I buy a new device that comes with version X, and there's a free software alternative version of this version X. There's also the free software alternative version of the version X+1. So in this case, because no manufacturer can tell me now is the end of support, I can just, if I install the free software version, I can go on to the next version and maybe to the next version, and I can keep using my device and save a lot of natural resources this way. Also, not only I can install a new upgrade of the initial operating system, it would be even more beneficial if you can replace it with another totally different operating system, like when my phone is not working anymore, I don't want to use it anymore, and I can reuse it, for example, in my personal home infrastructure for my automatic water system or something like that. And in order to do that, that's my second point, what we need is, we need general purpose devices. Our phones are as powerful as the computer who shot the first rocket to the moon. So why wasting them away just because the operating system is not updated anymore? We can just use them for another purpose. When we have the right to install alternative software and operating systems, that would be a big step towards a more sustainable digital society if we unlock these technical legal restrictions that hinder us today. Until we are there, so until we have the solution, or we can use any device with the software that we like to use it with, until we are there, we have another solution for a problem, because this is the solution we just had, the problem we just had. So I have a device, there's the end of support, and there's the end of hardware. But we can solve that solution if we upcycle the software, meaning if the manufacturer has an obligation to publish the source code after the end of support under a free software license, then a third party can pick up the code, upcycle the code, like develop it further, and give the device a second life. Of course, this is not a law of nature that this will happen immediately or something, but it is to expect it that with very popular devices, it will start that there's some company, community, someone who upcycles the software in this way. And the more we see that happen, the more repetition will follow. And this way we enable an aftermarket after the end of life of the software and save a lot of resources again. So this is the third point here, the upcycling of software with an obligation to publish the source code of a manufacturer under a free license after the end of support to stop linear product waste through software obsolescence, the problem we just had before. The last issue we have here, that I pick up today, is the incompatibility of products. So that's another big issue. So we have a problem. I buy a product from one manufacturer and that cannot talk with the product from the other manufacturer, which is very artificial, because if they would like to speak to each other, they could. It's just artificial, because they want to create island solutions, so that if I once decide for one manufacturer, I should keep in that family of products. But this ends in a situation where I maybe have 2 or 3 products from different manufacturers, and then I cannot combine them, and then I have to waste 2 of the 3 and choose the other one, and this seems very unsustainable. So in the industrial age, there was the solution of standardization, which is very important here in this regard, and it was very important back in that time for analog standardization of things. Digitally, we can do this a little bit more smart, I would say, with an interoperability. So the obligation to have interoperable products via open standards and open drivers interfaces, this will be, especially thinking back with the exponential growth of smart everything, of the Internet of Things, this will be key for not wasting millions and millions of devices just because they're incompatible with the next version of, or with the product of the other manufacturer, and also avoid this way monopolies of things. Yeah, so this will be basically interoperability of things, and this is so my fourth point here that I want to make today. The ability to combine and reuse different hardware and software via open standards, drivers, and interfaces, and via this we are able to transform the Internet of Linear Things into one of the reusable devices. And thinking back again, this is very important because the production of devices is that what has the biggest footprint. So whenever we can reuse a device, we can use it longer, we can combine it with some other device, a lot of natural resources are saved, actually. The last 2 points I made, like the publication of source code and having open standards and interfaces and drivers, that is also very important for the right to repair and to enable third party for repairing devices. We will hear later in this same track more about this. Just here as a side note, so other initiatives also benefit from the principles that we just talked about. And here's the summary again for reminding that. So the 4 principles I think that we need for a more sustainable digital society is the reuse and circular use of software. So especially with the upcoming public infrastructures and things that we see there. The general purpose devices, so we have the right to replace the operating system and software. The upcycling of software, so we can avoid the problem more of this software obsolescence and reuse the devices after and of support by the manufacturer, and the interoperability of things. So we have the ability to combine different things and
I'm
set
afraid
up
we really have to wrap it
really
up.
in a smart way.
Eric,
Okay, it's 10 seconds saying, okay, so thank you very much for listening.
Thank you
I'm
very
sorry
much.
he was saying 10 seconds.
thank you. Hello everyone and welcome. After Eric Albers introduced us to the concept of sustainability and how it relates to software, our next speaker will deal with a more technical and practical aspect. How can we make sure that software is resource efficient? And if we make sure that it is, how can we then measure it and then evaluate it? For this, I will give the floor to Joseph Divot-Gais from KDE.
Thank you very much, and thanks to the Free Software Foundation Europe for accepting the proposal, as well as to the Umweltbundesamt who's funding the project that I'm working for, called Blauer Engel for FOSS. So I'm going to talk about sustainability in a slightly different way now. I'm going to talk about the energy and resource consumption related to software, and how to recognize energy efficient software with Blauer Engel eco-certification. I'd also like to announce that we now have a website that launched today, eco.kde.org. You're welcome to check it out. An overview of what I'm going to talk about. I'm going to first present the KDE Eco projects, as well as the Blauer Engel Eco label. And then I'm going to go through 3 steps to obtaining eco certification for software, and then wrap it up with looking to the future. If you'd like the slides, I have a lot of links that are in here. If you'd like them, you're welcome to download them from GitLab at event.kde.org/Joseph/BE for FOSS. I will have that link again at the end of the slides. So to frame the conversation, I'm going to first present a discussion of software bloat from the Blauer Engel award criteria, which were released last year in January 2020. They write, the availability of more and more powerful hardware has resulted in software becoming more and more bloated from version to version, so that more resources are required for only minimal or even no enhancement of the functionality. To illustrate that, here's a bar plot. The x-axis is various software. I'm going to focus on the far left 2 plots here. On the y-axis, you're looking at the watt hours. And this is comparing, in the green, word processor 1 versus the blue, word processor 2. These are word processors running on the same hardware doing the exact same task. And the word processor 1 has about 4 times the energy consumption of word processor 2. In some sense, you can talk about sustainability here as being the relative sustainability between the 2 word processors. Word processor 1 requires less resources and is therefore more sustainable. To compare this to other things like light bulbs that you might know, running a 50-watt light bulb for half an hour would be the equivalent to running word processor 1 for only 7 hours, in comparison to word processor 2, which you get 27 hours of use time out of that for the exact same tasks. Okay? So this is to illustrate that there's an interdependency between software engineering and environmental issues. Here, resource consumption. It's not just the energy consumption, it's also software bloat can result in hardware becoming obsolescent, meaning that the perfectly functioning hardware, as Eric talked about earlier, can then become unusable because the demands get higher and higher with new versions of software. So KDE Eco is a new project. We're looking to explore the energy efficient software world in various ways. One is to push a conversation on the environmental impact of software. We want to be pioneers in developing energy efficient software. We want to promote tools for measuring energy efficiency, which I'm going to talk about today in terms of energy consumption labs. And we want to certify free and open source software with Blauer Engel Eco certification. So in general, our goal is to put free software at the forefront of energy efficient software. And we have many channels to get involved. We're going to have 2 sprints coming up in the next few months, one in December to set up our community lab, and one in early February 2022 to start measuring free software. We have a mailing list and a matrix room to have conversations about the topic of energy efficient software, a forum channel, etc. And I will present a list of various ways to contact us at the end. So KDE Eco is made up of 2 projects. The first one is a community-driven project. That's the FEEP project, the Free and Open Source Energy Efficiency Project. And the goal here is to collect energy consumption measurements and to integrate these measurement tools into the development process. The Blauer Engel for FOSS project, the project that I'm working for, is supporting FEEP by collecting, summarizing, and spreading information about eco-certification with Blauer Engel and energy consumption measurements. And one of the main takeaway messages I want to have today in the talk is that free and open source software is particularly well positioned for obtaining a Blauer Engel eco-label, as we'll see in the 3 steps to getting eco-certification. So what is Blauer Engel? I imagine some of you might know it here. It's a German eco-label for environmentally friendly products. It's the oldest in the world since 1978. It's recognized by 92% of Germans and highly regarded internationally. And it's awarded to a variety of products. So most Germans, when you talk about Blauer Engel, they immediately think of paper. That's probably the most common association, but they award it to various products, including laundry detergents, cleaning services, as well as construction products, etc. And since last year, also for software. International perspectives on the Blauer Engel. So 15% of the recipients are outside of Germany, so it's a German-based and German government-backed eco-label, but the recipients are international. One of the nice things about this eco-label compared to other eco-labels is there are no requirements on where a product that receives the label can be marketed. Worldwide, it's seen as a mark of quality or quality assurance. For example, if a company is building a building in another country, they might choose Blauer Engel products because they will be more assured that it's environmentally friendly and of a higher quality. For companies, the award criteria of the Blauer Engel are seen as indicators of the direction of the European Union market, as well as a potential guideline for optimizing their own products, whether or not they apply for then Blauer Engel certification. And the Blauer Engel is a member of the Global Eco-Labeling Network, which is an international cooperation to define common core criteria for eco-labels across borders. KDE is very interested in Blauer Engel. We already have the Kmail email client and Ocular PDF reader measured, and the application is ready to submit. The digital painting program Krita has been measured, and we prepared the application. In early 2022, we're going to have a measure-a-thon. You all are welcome to join. We're going to measure the text editor more Kate, as well as the educational software G-Compris, and we're open to other projects, free and open source projects, if you're interested. Why are we interested in Blauer Engel? Well, there are many benefits to it. One is it recognizes, when you receive the eco-label, it recognizes that you have high standards in environmentally friendly software design. It differentiates KDE and free software from the alternatives. It increases the appeal of adoption for users and institutions. For example, the green public procurement. And it shows transparency in the ecological footprint of the software. What is green public procurement? It's the process whereby public authorities seek to procure goods, services, and works with a reduced environmental impact throughout their life cycle, meaning that this might increase the adoption in institutions of software in official capacities. Okay, so now let's get to the what I'm calling the ABCs of the Blauer Engel eco-label. There are 3 main categories in the award criteria. The award criteria now are only for local software. In future revisions, they want to include client-server software as well as mobile phones, but at the moment it's only local software. The three main categories include resource and energy efficiency, similar to what we saw at the very beginning with the bar plots. How much does the software consume? The potential hardware operating life, that's related to things like upcycling and other ways that software can influence the hardware life cycle, as well as user autonomy. So in a bit more detail, today we're going to focus mostly on the hardware performance and energy consumption part. But the other requirements include things, in particular under user autonomy, things like does the software support open standards? Can you completely uninstall the software without leaving a trace other than the user-generated data? Is that documented somewhere? Is the software open source? Is there continuity of support? Can the user decide to install only the essential functions without all of the other functions that they may not need or want? And can the software run offline, and can the user choose not to have advertising, which is also a drain on resources? So we're going to focus on this for right now. So 3 steps: measure, analyze, certify. Measure energy consumption at, for example, a community lab. We're going to set one up in December in KDAB Berlin. Once you have the results and the data, you can use a tool like Oscar, the open source software consumption analysis in R, to analyze the data and get a report, which can then be used for your application for Blauer Engel. And then you can certify it by submitting a full report with the ABCs of the Blauer Engel criteria. What do you need for a lab? You need at least 2 computers and 1 power meter. The primary computer is the system under test. This is the computer that's going to be running the operating system that you choose with the application installed. And then it's going to be connected to a power meter as well as a data aggregator. Power meters, high-powered power meters, are expensive. And a KDE community member, Volker Kauser, has hacked a cheap power meter, costs about 10 euros compared to perhaps 300 plus for a more powerful power meter. The data, the sampling rate is lower. You get about 5 samples per second compared to a more high-powered power meter where you get up to 1,000. But for 10 euros, you can do quite a bit with that already to get a sense of how much energy your software is consuming. To get a visualization of the lab setup, you have the system under test connected to a power meter, and the power meter and the system under test are both connected to the data aggregator. The system under test will also be collecting data, which then will be used to analyze, which includes the performance data, the hardware performance. That includes things like the CPU, the memory, the disk, and network data. There's a free and open source tool that can do this, Collectl. And the power meter is collecting then the energy consumption. One of the recommended power meters is the Gouda Expert Power Control Meter. This is recommended by the Blauer Engel. There are others that you can use. Janica is another one. Then what do you measure? So there are 3 different scenarios to measure. One is the baseline measurement. This is just the operating system running without anything happening. That gives you the underlying power consumption of that OS. You have the idle mode, which is the operating plus the application running, but nothing happening. This gives you, when you subtract out the baseline, you get then the energy consumption of just that piece of software when it's not doing anything. And the standard usage scenario, which is the application being used. And it should represent typical and frequent functions of that software. This is a step that needs to be defined before you measure, obviously. And there are many ways to emulate this. Right now, there's a lot of discussion in our matrix room about, so, okay. There are many emulation tools. One that's been used by some researchers in this area is Acciona. It's a quite easy to use, but pixel-based tool. Pixel-based means if you change monitor sizes, you might have problems reproducing the tasks because the pixels have changed relative to the monitor. But there are various other tools, and right now we're in discussion about which of those tools we want to use in the sprint in early 2022. If you want a summary of the various tools that can do this emulation of the standard usage scenario, there's a list here at the GitLab repository from one of KDE's members, David Hurka. At the moment, these standard usage scenarios are freely selected for Blauer-Engel certification. In the future, they may become standardized. And one thing to note is that for Blauer-Engel certification, you will need a log file of what actions were taken. So the kinds of things that you might expect, for example, when measuring something like an email client is opening an email, sending an email, adding an attachment, reading through the email. These are all standard usage scenario tasks that then go into the standard usage scenario that goes into the energy measurement. So that's the measurement part, step one. Step two is analyze. The Umweltcampus Birkenfeld has developed an online tool to produce reports automatically. You need a log file of the actions taken for both the idle mode and standard usage scenario, as well as the energy consumption and hardware performance results. You feed that into Oscar, the open source software consumption analysis in R tool, and what you get back is a full report with the energy measurements, the hardware performance, etc. Here is just an example of the Kmail report. This is a standard usage scenario, and the gray lines here represent 31 repetitions of the measurements, and the importance of doing that is so you have a statistical valid data set that you can then use for analysis. Each of those gray lines represents, at each second, an average over 1,000 measurements with the Janitza power meter. And if you look here, what you see here is the power consumption over time. And this is, for example, at the point when sending an email, and you see that the power consumption goes up. With this report, you are now done with the first part of the resource and energy efficiency component of the award criteria. What's really nice for us as free software enthusiasts, developers, etc., is that everything else here, free and open source software already does, in most cases. All that's missing, if it's missing, is documentation. So we're in a really great position here to get recognition of environmentally friendly software design once we have the energy consumption measurements. Looking to the future, we have the idea of doing a KDAB community lab. This is already in progress. We have a planned sprint in December. Again, you're all welcome to join if you would like. Long-term vision is to have a software upload portal where steps 1 and 2 are done automatically. You specify the hardware you want and you get a report back. The short-term goal for now is just to get a lab set up. We're going to document the entire process. If you would want to set up your own lab, you can either look at our documentation or get in touch with us. We'd be happy to help get more labs set up to measure the energy consumption of free and open source software. There are many other ways to help. Started labeling in KDE, Bugzilla, efficiency bugs. Those are bugs related to CPU spikes, delays, hangs, etc. You can provide support for statistical analysis tools, submit Blauer-Engel applications, help with promotion and outreach, give us feedback for revised criteria, and help develop automation tools. Okay. I'm actually almost done anyway, so for the last point, the development of automation tools. There's another project also funded by the Umweltbundesamt, which might be of interest, is the SoftAware project. This is a project between the Sustainable Digital Infrastructure Alliance and the Öko-Institute, and they're specifically focused on developing CI tools to bring energy efficiency measurements into the CI pipeline. And they're very interested in getting community support, and they have various hackathons and workshops planned for the next 2 years. And just to point out that if you want to learn more about this project, there's a conference presentation coming up in February. If you'd like to get involved, we'd love to have as many of you join us as possible. You can contact me at joseph@kde.org. I just started a Mastodon account for the project. We have 2 sprints, as I've mentioned several times now, one in December, one in early 2022. We also have a regular monthly Big Blue Button meetup on the second Wednesday at 7 o'clock CET. Contact me if you'd like to join us. We just had our meeting 2 days ago, and it's been lively discussions about things, for example, which tools do we want to use to emulate the standard usage scenarios. We also have an energy efficiency mailing list and a matrix room, and there, again, you're welcome to join it and then join the conversation. And then if you want some community support in general, we have a forum page. Here's just some more links, the GitLab repository for FEEP and for Blauer Engel for FOSS, as well as our promo. And the Blauer Engel applications that we have completed, you're welcome to take as a template for your own software. And hopefully we can get as much free software certified as possible. So that is it. I just want to note that this was funded by the BMU, which is the Federal Ministry for the Environment and Natural Conservation and Nuclear Safety, as well as the Umweltbundesamt, and we are responsible for all the content. So thank you.
Thank you, Joseph. And I'd like to ask if there are any questions from the audience that you would like to ask Joseph. No. Yes, Max, please. Could you please come over, though, so that also the people who are online can hear you? And if you could speak to the mic. And I think you can also remove your mask for it if we... Thanks a lot. No, it's the microphone over there. Sorry. Yeah. Thanks a lot.
Okay. So thanks for this presentation. I was wondering, does it really make sense to have like pure CLI tools also to be certified, or is it rather focused on desktop software, user-facing software? Like, what's the threshold where it really makes sense to make a software having Blauer Engel?
So at the moment, the measurement labs are the way to get the reports for the Blauer Engel, and the CI tools is more of a long-term to bring energy efficiency into the development pipeline.
Okay.
So that we can get a sense as we're making commits if we're changing the energy consumption. But
I think I was perhaps unclear. Like CLI tools, like pure console tools, like which you have in the terminal. So does it make sense to have it certified?
So as far as I understand, that's not part of the award criteria for Blauer Engel, that they would require external measurements. And I think part of that is because there are things that don't get picked up by the CLI tools, is one of the issues. Another one is that it itself is going to be creating some energy consumption. Okay. But I think the main one is that having this external, you have an objective measurement of the energy consumption. Naturally, that's going to be when you don't have a battery that could also then create issues. So laptops might cause problems because there's other kinds of energy management that's happening. But you want to have this sort of objective measurement that's external to the computer itself. I think but for the Blauer Engel, as far as I understand it, they need this kind of report at this point. Good. So having the command line tools may not be enough.
Okay, thank you.
You're welcome. Thanks for the question.
Thank you. Are there any other questions in the audience? Eric, please, could you come? Thanks a lot.
So is there already software that has the Blue Angel, or when do you expect the first to have it?
That's a good question. No, not yet. And this is something that we're excited about because, fingers crossed, if we get these applications in the next few weeks, that maybe KDE can be the first, which has a certain symbolic value.
Sure. And when do you think that could be?
So we plan to submit by the end of this month, early next month. There are just a couple of things we still need to work out in the reports to make sure we understand what's happening and what the values are that we're reporting. Yeah.
Thanks.
Yeah, and on that note, whenever the Blauer Engel awards a product for the first time, they have a big event with various politicians and whatnot, and it also would be nice publicity for free software.
Thank you. Any other questions for Joseph? No? Joseph, thanks a lot for joining us.
Thank you. Thank you very much.
hello, and for those of you who just joined us here in the audience and also online, welcome to the SFSCon and to the sustainability track. Is Anne Mullen. She is a project manager in Sustain. Sustain is a project that aims to create a rating system that measures and evaluates the sustainability of AI. Anne Mullen, we are looking forward to your presentation.
Hi, okay. I hope you can hear me.
Yes,
So
I
it's
can
good.
hear you.
Great, because we
Hi.
had some technical hiccups, but I hope everything is in order now. So I'm going to change to my presentation. I have the feeling you can't see me, but I'm going to change to the presentation, and I hope that you'll be able to see that.
Great.
Okay.
Yes, we can see you. We can hear you.
Okay, I'm having a bit problems hearing, but I'm going to start, and I don't really see you right now, but if in case there's something going wrong, just talk to me and I'll be able to adjust probably. So yes, thank you for the invitation to speak today at the conference. I'm a policy and advocacy manager and project manager for Sustain at Algorithm Watch. And Algorithm Watch is a non-profit research and advocacy organization that is committed to watch, unpack, and analyze automated decision-making systems and their impact on society. So with Sustain, we want to look at the impact that AI systems might be having on, society in a sustainability sense and on individuals. So what I want to do today is I want to give you a short introduction into the project and what we are doing, but I'm really interested to hear your perspective from the free and open source software community on the sustainability of artificial intelligence, and really want to exchange with you. So what we're interested in is that when we started the project, and when I talk about we, I'm talking about Algorithm Watch and our two partners that are, which is one is the IUW in German, the Institute for Ecological Economics Research, and the Distributed Artificial Intelligence Laboratory at the Technical University of Berlin. We are funded by the German Ministry for Environment. And so when we started this project, our idea was that we could see an uptake in the discussion about AI for sustainability. So how can we use AI and machine learning to, come to more sustainable solutions, to have, like monitoring systems for sustainability issues, etc. But we saw less of a discussion on the sustainability of AI. And even though we are currently, becoming aware of huge energy costs that we have with AI systems. We have bias in data sets. We have problems with dequalification of workers when AI systems enter into, the area of work. We have strong market concentration based on AI systems. So we are kind of aware of all these problematic developments. And this is kind of this lack of discussion on these unsustainable developments also means that we don't have a discussion about how to improve it. So this is kind of what we are aiming for. We want to start the discussion and we want to raise awareness on how we can make AI systems more sustainable, because there are huge potentials and we just need to have this discussion to, benefit from these potentials. Based on the examples that I just given you about the problematic developments that we are, seeing, you probably already became the idea that we're not only looking at ecological sustainability, but we're focusing, or we're following a nested dependency model of sustainability. That means we're not looking only at ecological sustainability, but also social and economic sustainability. So overall, and this is kind of our working definition, sustainable AI should respect planetary boundaries, because, this is the basis. Ecological sustainability is most important in a sense, but it should neither endanger social cohesion nor aggravate problematic economic dynamics. So, like I said in the outset, we from the start, we didn't even have an idea how, what sustainable AI could mean, how we could even measure it, how we could, go to an industry partner and then say, okay, this is sustainable, this is not sustainable AI. So what basically my colleagues did in the first step is that they looked at all the literature that is already out there, and they did like a meta-analysis of how different indicators for measuring sustainable AI in an ecological, social, and economic sense might look like. And again, you see it's based on the nested dependency model with these 3 dimensions. And overall, we were able to identify 12 different criteria across these 3 dimensions. And then each of these criteria, you would find a number of different indicators which we are now using for operationalization to make the sustainability of AI measurable in a way. To give you some examples, in the ecological dimension, we would be looking at energy consumption, for example. So are there any methods in place to optimize energy efficiency, for example, by compromising models, by small data approaches? Or is the indirect resource consumption considered for? Is hardware sustainable? Is it being reused or recycled? And what kind of energy mixes are being used in data centers, for example? If we look at the social dimension, and you take non-discrimination here as an example, we would, for example, be asking someone, okay, if you have this AI system, do you test specifically for potentially marginalized groups? Do you identify potentially marginalized groups, and do you actually test specifically for them? Also, cultural sensitivity. So is the system, or are your systems designed in a way as to allow for retrain options so that we can adapt to different data sets from different cultural contexts, to make the system more culturally sensitive. And if we look at the economic dimension, it would be, for example, something like we would be asking about the changes in working conditions for people who are affected by the implementation of an AI system. Does it lead to dequalification for workers, or does an organization offer retraining for workers affected by an AI system once it has entered their scene of work? So these are overall some criteria and indicators. It just gives you a first glimpse. But now I want to talk more concretely about the potentials of free and open source software for the sustainability of AI. And I want to give you 3 examples here. Again, from the ecological point of view, we could be looking at energy consumption. And from a FOSS perspective, I think what's an interesting point here, where it aligns quite nicely, is that we are here addressing if energy consumption is considered at all in the development process. And I think the idea of, making available pre-trained models would be a great way to reduce energy consumption. So this is a potential I see in the free and open source software community to, make available pre-trained models. And this might even be more, resource friendly than just releasing the training code or the training data under free licenses, because training time is still expensive and resource intensive. If we look at the social dimension, we could be looking at the criteria of tech robustness and human oversight. So here we are, for example, interested in ensuring data quality, and data quality could be something like data sets are representative, they are fairly recent, they are complete, and similar things. So open data sets offer themselves obviously better for auditing these data sets. So we have better oversight and better, ground for doing actually auditing of data sets. In the economic sense, if you look at market concentration and innovation potential, closed data pools lead to more market concentration. So the idea of having open data pools, they contribute towards a more fair market and towards promoting innovation. It prevents lock-in effects because more competitors can actually develop AI systems, and they can offer equal services when they can make use of open data pools. So to conclude these, FOSS sustainability potentials in a way. I think there are some alignments, and this is just my view of the situation. Some principles of free and open source software align with our sustainability indicators, but also a lot of indicators are not specifically addressed by FOSS principles. But I'm really interested to hear your perspective on this. So do you see further potentials, when thinking of the indicators and criteria that we have identified? And also I would be interested in your perspectives on how to promote the sustainability of AI. So we are aware that we need to raise awareness, and we also need to address the regulatory level. Yes, so I'm really happy just to get into a discussion exchange. Happy to answer any questions that you might be having. And I'm closing the presentation now and hope that you'll be able to see me. It didn't work before, so let's see if it works now.
Hi, Anne. Thank you for your presentation. I cannot see you at the moment. Yeah. I still do not have a picture from you, but maybe you could at least return to the slide of your open questions so our audience can still see it.
Yeah, let me try. I had problems before when I was changing screen sharing back and forth.
Yeah, that is a new experience for all of us, but with this opportunity, I would like to thank everyone who is working for this behind the cameras, behind the sound.
Okay, so I've changed back to presenting, to sharing my screen, so I hope that you might be able to see it.
For the moment, I still see your avatar, so not the presentation.
Okay. So I would say let's just go ahead. I can re-enter. That's the only thing that works. So I can leave and re-enter if that's an option for you.
We do have time for you to do this if you want to.
Okay,
All right,
great. Let's do it.
See you in some seconds.
Okay,
yes,
here we go.
Yes, it works now. Okay, lovely to see you. Great. Oh, okay. Now we lost you.
Okay. I'm sorry.
All right, that's okay. Could you at least share the slides? Perhaps we could try this.
Yeah, let's try.
All right.
It doesn't show. I'm sorry, it doesn't show in my screen.
That's okay. That's okay. Then we can just talk. So I would like people from the audience to think if they have any question for Anne. Until then, I would like to share my personal comment that I really appreciated that as sustainability criteria, you also added social and economical aspects, as well as the ecological, of course. I think that's very important. So, yes, please, could you please, if it's easy for you to step to the microphone, and you can also remove your mask for it, so that people online can also hear your question. Hello. What's your name?
Hello, my name is Michael Marchnik. Thank you for the presentation. I just had a question. You said FOSS doesn't align with the principles of sustainability in AI. Could you give an example or like further elaborate on where those like discrepancies might be?
Okay, yeah, so it's probably, I didn't really express myself very well then if that came across like that. So in these three examples that I showed, I wanted to show that I think there are some principles of FOSS principles that align, by default with the criteria that we identified. So by default, we can say this is a sustainability criteria or indicator checked because it's a FOSS principle. They just align, it's the same thing. For other, it's not by default. For other principles, it is not necessarily by default that, FOSS principles by default mean a sustainable AI system. So we have one criteria that we are using when it comes to bias. We are.
I'm sorry, I will have to interrupt you, but our time is unfortunately up.
Okay.
Maybe you can take like 10 seconds to really
Yes.
wrap up your answer for
So-
this. Thanks a lot.
Yeah. To wrap up, we are thinking about identifying stakeholders to include in the development process, and this is not necessarily a FOSS principles, but it could be. You know, it could be in a project. Thank you for the question.
Thank you.
Thanks, Anne. Hello everyone and welcome to the SFSCon. Should we have a right to repair our devices? The right to repair our devices is of support in Europe. But the issue often comes down to software, that it makes a device obsolete. So how can free software contribute to the overall right to repair movement? With this question, I would like to invite our next speaker, Ugo Valori. Ugo, nice to have you here with us. Hello.
Hi everyone. Great to be able to join, although I wish I could be with you all in person in Bolzano. So I'm gonna start. Thank you for the introduction. Let me share my presentation. Hopefully it will be working okay.
Perfect. Great, it works and we can see.
Brilliant. Okay. So a key issue is right to repair is starting to be a topic that people understand about, that people are talking about. We've been, as organizations working on the ground, we've been working on this for a few years now, but it's starting to become one of those catchphrases. And part of this is excellent because it accelerates perceptions and potential opportunities for coming reality. But at the same time, there is also a risk that with right to repair, governments, legislators, policymakers end up understanding something different from the real right to repair that campaigners have been fighting for many years. And I will talk about a little bit of this in the presentation. So first, I'll just introduce the European Right to Repair campaign. My name is Ugo Valori from the Restart Project in London. We are one of the co-founding members of a European Right to Repair campaign. And the campaign starts from the perspective that there is a really high unsustainable environmental footprint of all the products that we use and that we keep buying and manufacturing. And therefore, we need to change this and ensure that products can be used for longer before becoming waste. And this has to do with the embedded energy that they have and all of the materials and the energy impact that the materials have in order to mine them, assemble them, create the products, and then all the way to shipping them to us. And the right to repair is a way for us, people, citizens, consumers, communities, to regain control over the things that we own and make sure that we can decide until when it is okay to use them and not be told that we can't use them any longer. The campaign features members of various kinds across most of Europe. We already have 89 member organizations in 18 European countries, and that includes community repair groups, sustainability activists, academics, environmental NGOs, and other, including professional repairers and companies increasingly interested in this as an important space, whether they supply spare parts or whether they're interested in the reuse economy as platforms, for example. And I'm presenting the campaign here because I think there might be some of you in the audience today and among the other speakers that might want to consider how you might be able to contribute to the campaign in the future and how we might be able to bring together the issues that we are campaigning for with the issues related to free software, as they're much more closely interlinked than we might think. So the key pillars of right to repair until now have been the importance of good design. So products that are possible to disassemble for repair, and products for which there is fair access to spare parts and repair information. And looking into the future, the importance of informing consumers so that people can make a good decision with all the information available to them at the point of sale for when they're buying a new product, and to know whether how that product is actually repairable or not, or how long might software support be guaranteed for that product, for example. Things that are currently sorely missing, although there is a little bit of hope that in the future this might be a little bit better. So this fits into a wider context of policies at European level, although the campaign also engages with countries and national policy level beyond the EU specifically. But there's the bulk of work that's happening in the EU. There was a circular economy action plan approved last year, and eco-design repair requirements that were approved in 2019 and finally came into effect. I'll mention them in more detail in March this year. And then there's a series of initiatives on empowering consumers for a green transition, and more work happening on future regulations that might become into effect in the next 2-3 years. And the big milestone for all of us has been this new regulations on energy labeling and eco-design that have been approved in 2019 and that finally came into effect this year in March across Europe, so that for a range of products, and we're talking about not the most obvious products that we normally think about when we think about the free software movement, but we had to start somewhere. TVs, fridges, and freezers, washing machines, dishwashers, but servers as well. And for the first time, there are some repair-related requirements for some of them. And these requirements are that for the first time, there is a series of key parts that need to be made available and need to be available when taking apart the product, so improving the design so that it's easier to repair them. And these parts need to be available in legislation for 7 to 10 years after a product is removed from the market. So this starts giving people a better understanding of what is the projected lifetime of products, not just when a product is stopped being sold, but actually there is an afterlife, which I think is particularly important from the context of pushing for free software in the future. Then there's other aspects on making repair information available, and with some caveats, unfortunately, that for the first 2 years since the product is put on the market, manufacturers wouldn't be required. They could choose to do this, but they wouldn't be required to make the information nor the spare parts available widely on the market. But there are still a lot of important barriers in this legislation, and some of that is obviously it only applies to a certain number of products. And there is a big distinction between the amount of information and spare parts that will be available to everyone, as opposed to those made available to professional repairers. There's a bit of potential conflict on the definition of who is a professional repairer, which could leave up to manufacturers the opportunity to limit provision of parts to some professional repairers closer to their official networks, but not necessarily as much to all professional independent repairers. And like key aspects, you'll see them in this last 6, 7, and 8 points, but these are really the key aspects that are the heart of our future campaigning, is that these legislations come from a perspective of eco-design, so on limiting energy consumption in use or energy consumption in manufacturing increasing. And so because of that, pricing was not really a criteria, but it's obvious to everyone that pricing needs to be a criteria taken in consideration for all of this to happen. Otherwise, people might not find it particularly attractive or convenient or even possible financially to keep repairing things if it costs too much. And crucially, the pricing is kept virtually high, artificially high, by bundling some key parts of this spare parts together, so that even if you have a fault on a small spare part, occasionally that part might be sold packaged together with other parts, which really limit, increases artificially the price. And software remains virtually unaddressed, and I'll go into a little bit more detail shortly on this. So what needs to happen? We need more product groups to be taken in considerations. When people talk about right to repair, people think about a much wider range of products. It's not that you only care about your washing machine being repairable, but you want your laptop being repairable, your coffee maker being repairable, your wearable products to be repairable, your smartwatch, and so forth. And we need more inclusive repair markets, so that whether it's a firmware update, whether it's a spare part or a piece of repair information or the schematics of a product, they should be made available to everyone universally, and not just to professional repairers, which is a useful start, but it might drastically limit the range of impact, environmental and otherwise, that we can make with all of this. And also, we campaign for a European-wide repair index that might make it easier for people to understand when they're buying products, what it is that they're buying, and whether that product, there are some trade-offs with regards to length of software update support provided or otherwise. But indeed, the big elephant in the room, and you're probably wondering, well, why are you telling us about all of this about spare parts and repair information? And the real topic of this talk is software. I've kept it a bit frustratingly as such, because the truth is that software has been neglected, drastically neglected until now when it comes to right to repair. And there's various ways in which this has happened, and there's also some misunderstandings about what has been already included in the current regulations on these initial product categories. And I'll go now a bit more into that, but also there are some rays of hope. So don't lose hope halfway through. So existing regulations only require manufacturers to make available the most recent software update up until the end of product support. So what this means is that, let's say you are a manufacturer of a product, and you release a product, like a connected product that has an underlying piece of software embedded within it. And you realize a month later that that product needed one update because there was a bug or a security threat. Currently, once you publish that first update, as long as you make that update available for 7 to 10 years, depending on the product categories, until the end of the projected support period, you will be complying with the regulation. So this regulation does not require manufacturers to keep supporting products with additional updates to the software, to the security packages for long. at all. And there's been some misunderstandings in the wider community, thinking that actually this was a good start, but it's actually quite meager and seems a very light touch way of saying that if you are a professional repairer and for whatever reason you have to reset a product, and then you'll be still able to access the support patch released maybe 5 or 6 years earlier, but that doesn't mean that the product will continue to be supported, unfortunately. But there are some useful opportunities coming up. We are currently in a series of rounds of feedbacks on a draft regulation for eco-design for smartphones and tablets, and we expect this to be approved in the next year by 2022, notwithstanding a lot of tensions between different agendas of manufacturers and the organizations that represent them, and environmental organizations and campaigners such as ourselves. Why is this interesting? Because for the first time, actually, software is mentioned more prominently, and there is an understanding that bringing minimum support for a number of years for software and security updates is necessary in order to reduce unnecessary fast recycling and upgrading cycles across Europe. And this could be game changing also because such regulations approved in Europe could really change the future of how manufacturers start thinking about this for other countries as well beyond Europe. I left it at X because currently this is still in negotiations. We are hoping to see a 5 years support at least for software and security updates, but we would love to see a lot more than that. And why so? Specifically smartphones. This is a picture from a model that was very popular a few years back, but I chose this one because unfortunately it's not changed. The proportion of how much of the environmental impact of a device like a smartphone occurs before you've ever switched it on is staggering. It's approximately 80% for the vast majority of models. So that means that very first time you switch it on and you do your first software updates, well, the vast majority of its environmental impact has already occurred. So the only way we have to increase the efficiency and reduce our footprint on the planet is to keep these products in use for as long as we possibly can, which unfortunately often is a long more than the manufacturers themselves are prepared to support them. So as part of our work as a campaign, we've launched a provocation with a European Right to Repair campaign with a 10-year phone campaign, which you can still visit. And that looks at some key criteria. And one of them is, well, if phones need to last 10 years, then we need 10 years of software and security updates. Why not? Why does it have to seem like too much to support a phone for 10 years? It's just been so ingrained in our lives that smartphones are products that we keep upgrading every other year, that even the thought of thinking that 10 years support, many people have even questioned whether we understand that technology does change and improves. But critiques of such campaigns don't necessarily understand that the full lifetime of a product is not necessarily just in the hands of people that are very technology savvy and might need, for whatever reason, to upgrade for specific extra functionalities. But there's a secondary market and a tertiary market, and people can continue to benefit from these products particularly if security and software are kept up to date. The biggest problem that we see, and I'd love to hear from you, how can free software could help, is that of part pairing. Now, part pairing, some of you have probably heard of this, maybe called serialization, and it has to do with how manufacturers, some more upfront than others, are more and more considering using pairing at software level of a device with specific spare parts, so that even if you are able to disassemble a product and replace one part, that part might lose functionality, some or completely, unless the manufacturer repairs it using the serial number of that specific part and makes it working again. This is huge because it could kill any independent repair industry, destroy jobs of independent repairers, and prevent anyone from doing any DIY repairs. We are fighting against this, asking the EU to not make it, to not allow manufacturers to include this in future regulations. But there is a lot of pushback, and we're far from seeing a positive ending on this. So free software, sadly, it's currently absent from any of the regulations. So when we campaign for a 10-year phone, we don't necessarily expect manufacturers to provide 10 years worth of software updates. Free software could be the solution. We could be requiring, as the Free Software Foundation Europe is campaigning about, for software to become to be released in free and libre format when a manufacturer stops supporting the product. Other options could be that users should always have all the freedom to uninstall and replace the software that come with that product with software that they're enabled to compile themselves or to access from trusted sources that can extend the life of products. Of course, there have been plenty of cases of this in the smartphone world, but the fact that some of these options do exist isn't enough, because they are widely out of touch for the vast majority of consumers. Like the vast majority of people that we see at community repair events, and not even mentioning them, like people at large, are not able to really do this software, this move to free and open source software completely. It's still complicated, artificially so, because of all the barriers that manufacturers are putting. So we see a real opportunity to change this, but in legislative terms, this is still extremely weak, and we don't see enough awareness for policymakers to do this. So we see an opportunity to combine the campaigning from organizations that work on digital rights, those such as Free Software Foundation Europe, that are working on pushing for more access to free software, and campaigns such as the European Right to Repair campaign, to bring together an agenda that doesn't necessarily create a friction between providing longer term support for all products with software and security updates, but at the same time creating an opportunity for more freedom for everyone to use the software they want. So that, if we talk about a 10-year phone, well, maybe for 7 years, manufacturers could support it directly, but they should not create barriers from earlier on for extending that support further. Anyway, I think this is an introduction to this, and I'd love to hear your thoughts, your questions, your challenges, and I hope it can be a beginning of a joint pathway towards reaching that goal together with all of you. Thank you very much. These are our contacts, and I'll be happy to discuss and take your questions.
Thank you, and I would like to congratulate you both that there are measures being taken now for our routes to repair devices, and also for the 10-year phone. I think that was a great idea, very catchy. And so I would like now to give the word to our audience and ask you if there is something that you would like to share, or if you have any questions for our speaker. And I'll try to correct this. Eric, please. Just one moment. Here you go.
Sorry, I come from the other side of the room. I would be in particular also, since you mentioned it, interested in what do you think, like, what would from the repairability factor of devices, what would be more beneficial, having an extended support, like 5 years, 7 years, 10 years of an obligation of supporting a device with software updates, or that, for example, a manufacturer can decide after 2 years or 3 saying, okay, there's no, let's say, economic benefit anymore in the device, I stop the support, but I I publish the source code under a free and open source software license. So what do you think would be more practical for repairers?
It's a really good question, and I think we are concerned that allowing manufacturers to, in a sense, wash their hands after 2 years and just say, "Oh, here you go, here you have your source code," might not necessarily benefit the vast majority of users that will still like to continue use their device, but might experience some barriers when it comes to moving from an open source alternative operating system for the product, if that's what you're hinting at, because it could work in other ways, but it would be important to understand if provision, for example, of software and security updates to an existing version of an operating system as it was provided by the manufacturer could happen with a trusted independent provider that would take over support without requiring to everyone to change completely operating system in order to get there. So that's why our campaign has focused on extending the requirements for manufacturers as a first step, because we don't want the benefits of additional repairability or continuing to expand the durability of a product to be reserved to those that might have the skills to install an alternative operating system using some of the source code that was released. But the choose, again, I think that the key aspect is avoiding a situation where these movements that ultimately want to empower users to keep ownership of the products that they buy for much longer than they are allowed to today. It's really crucial that these movements work together and find a good synthesis that kind of satisfies both agendas and aren't seen as like a contradiction. So kind of allowing manufacturers to sort of do as little as possible of their job and then moving on. Because the key aspect is that for many years, they've been very keen to keep releasing more and more products at all times, and not so keen on supporting the products that they're already putting on the market for long enough. And that is what really needs to change.
Thank you. I also think that we can combine the two demands easily. And I also have a question for you from someone from our online audience that I would like to share. It's Julio Roman, who asks, do you think it would be possible to stimulate the adoption of repairable products by easing the import of products manufactured outside the EU? For example, lowering taxes.
I wonder whether you see products that are more repairable being harder to access because of taxation at the moment. What we're seeing, and it'd be interesting to see where that comment comes from. And if you'd like to follow up further, I'd love to hear more. What we're seeing is the regulations at the moment, the eco-design regulations, are set up to prevent manufacturers that don't respect minimum standards from flooding the market with products that might be either not energy efficient or not repairable. And so that sets like minimum basic criteria to avoid that. I would be surprised that there's some products that are very highly repairable but currently hard to bring to the market because of existing taxation, but I'd love to learn more. I think what we need to do is increasing the level of consumer information, particularly through an EU-wide ambitious approach to a repair index score. Some of you might be familiar with the work that's happened in France, where an initial repair score index has come to fruition for some product categories. And for the first time, it scores products such as washing machines, smartphones, lawnmowers, and televisions, and a few others, in terms of their repairability, giving a score between 1 and 10. And the price of the key spare components is included, as well as the price of, as well as some points about software support. However, this doesn't sufficiently, in our view, make it transparent for anyone to check what are the underlying statements that manufacturers are making. And it also doesn't sufficiently differentiate between products that are extremely repaired and actually supported for long software-wise, and those that might be only partially repairable. So it's a good first step, but it needs to be followed up at European level by a better standard that actually focuses a lot more on the affordability of repair, as well as on long-term software support. And having access to free software should be giving a lot extra points to any product, because it might lead to strong communities that can support them well beyond the intended duration.
I would like to wholeheartedly wish you good luck to the Right to Repair movement, that you continue the success and gain even more legislations that help this cause. It's an important cause not only for sustainability, but for all consumers, that they don't have to waste extra money, but of course also for the environment now. So thanks a lot.
Thank you.
Software that was created decades ago is often difficult to find or to understand it. Will this be the case in the future? How can someone in the future read and understand the software that is being written today? For this, we will discuss the software heritage with the co-founder of the Software Heritage Project, Stefano Zacchiroli. Stefano, hello.
Hello, everyone, and thanks a lot for inviting me. I'm sorry I cannot be there in person, but I'm happy to be able to join virtually. And let me share my slides so that we can get started. Okay. Hello, everyone. Today we're going to talk about software preservation, in particular in the context of the Software Heritage Project. But let me start with a more general notion, which I believe is dear to many people active in free software and in general, people that care about the sustainability of various kinds of ecosystem. And that is the notion of commons. So commons, which in Italian we call beni comuni, are all those resources which are accessible to all members of society, and that encompasses various kinds of goods that are held in common and not owned privately. So this is very well known in the context of ecology movement, for example, for resources such as air, water, and habitable earth. But it's also relevant in the context of digital goods. In particular, there is this notion of the software commons, which is defined as essentially all computer software, which is available at little or no cost and which can be altered and reused with very few restrictions. And of course, at this conference, we are all into free and open source software. So the resemblance between this definition and free and open source software should be striking for most of the people here. And the first point I want you to think about is that essentially every time you or someone that contributes to free and open source software releases a line of code, which is released under a free and open source license, essentially that line of code becomes part of a greater body of things, of digital goods, which is the software commons. So essentially, we are all together creating and maintaining this body of knowledge, this body of digital knowledge, which is the software commons. And if you agree with that, there is a legitimate question of whether, aside from actually contributing to it with our own lines of code, we are taking good care of this body of digital code. Essentially, are we making sure that there is a sustainable future for the preservation of all this software that we are, in a way, producing together? And in fact, there are reasons for concerns, because like any kind of digital information, software, in particular free software, is fragile in the sense that it can disappear. It can be distributed today from a place that tomorrow might no longer be there. For instance, there's been a situation in which large forges and that were operated by for-profit companies are no longer available today for entirely legitimate business reasons. For instance, Gitorius, that some of you might have used, no longer exists today. Google Code, that for a while Google operated as a forge for collaborative software development, no longer exists either. Bitbucket, that still exists, no longer hosts some kind of repositories such as Mercurial repositories. So essentially, all the places that we use today to produce and collaborate around software are here with us today, but are not necessarily going to be with us in the future if you consider a long enough period. So essentially, imagine trying to find the history of a website, and most of you probably know that you can use the Internet Archive to retrieve old versions of a web page and see how it was years ago. But if a repository on GitHub disappears, or if GitHub as a whole 50 years from now disappear forever, where do you go to retrieve the source code that today is hosted there? And sure, if you have used Git, you know that Git is a distributed version control system. So you might say that someone should have a copy of that repository somewhere, but that will not necessarily help you when you need to find it if you don't know who has a copy of that repository. So this is the reason why a few years back, the idea dates to 2015, and we announced it publicly in 2016, we launched the initiative called Software Heritage. And the idea of software heritage in a nutshell is to collect, preserve, and share with everybody who needs it the entire body of software which is available in source code form. And we do this to cater for different use cases. So the first use case is actually to be a reference catalog. So essentially, archiving a place so that people can find and reference all software source code. So essentially, it's a place where you need, for instance, the part number of something that has been released as source code. You can go see if it exists and have an identifier for that piece of software. It's also meant to be an archive for archival sake. So essentially, if we agree that we are creating together an important body of knowledge that is stored in software source code, it is important to avoid that that knowledge is lost. So the idea here is to create a long-term place where if something is lost, disappears from its current hosting location, you can go to retrieve it in the future, no matter how far in the future. And finally, given I'm by main profession a researcher, I'm kind of envious of what our colleagues in physics can do in building amazing research infrastructure that are shared and used by researchers around the world when they need it. And essentially, the key idea on this point here is to build a research infrastructure where researchers who want to run experiments on source code itself can actually do that without having to recrawl the software themselves. So there is a body of research which is empirical software engineering, in which researchers often want to do analysis on vast body of source code. They cannot do that, so they do that on small samples. And here the idea is that you have a place where all the software source code that has ever been published is, so you can run your experiments in a reproducible way on the entire body of this software, and then go home and analyze your data, so while others can do similar analysis by themselves. So this is the general view of why we're running Software Heritage and the kind of use cases we want to support. We're also doing this in a kind of a principled way. So here you are, essentially, we want to be a piece of infrastructure that is helpful for the use case which I mentioned, but we're doing it following some key principles. So in terms of technology, the technology that we are building ourselves to actually create and maintain the archive is itself entirely free and open source software. And the project is run as a classic open source software project. So you can come, you can see our code, you can propose patches, they are reviewed, and they can be accepted and become part of the infrastructure themselves. We're also building it in a way that is fully replicated, because we know well that the only way to make sure that something will live on forever is to make sure you have enough copies of it. So we operate multiple copies of the archives ourselves, and we are also building a network of mirrors operated by other actors around the world, so that each one of them has a full copy of the archive as we have it. In terms of the content we archive, we are principled on the fact that all the pieces of code we archive are identified by intrinsic identifiers. I'm going to talk a little bit more about those in a bit. And we also make sure to not have, not store opinions about artifacts we store, but only store facts about them. So everything we store in the archive as an information about where it comes from. And instead of storing information like this software is opinion like this software appears to be under the GPL, we store facts like the license file at the top level director of this software says it is under the GPL, or we have run this tool and this tool run with this configuration and this version says that this software is under the GPL. In terms of organizational infrastructure, we are a non-profit initiative, and we are multi-stakeholders. So we have funding from public bodies, we have funding from sponsors, we have funding from donors, and we believe this is the best way to essentially minimize the influence that any single actor can have on a mission that we believe is for the good of humanity. In terms of what we actually archive, in case you want to know, in case you're curious about more details, essentially we replicate the data model that you find today in most modern version control systems. So we crawl places like a Git repository or a Subversion repository or packages from source code distribution, and we store all the versions of all the source code files we find there. So not only the version that happens to be as the most recent commit in a given repository, but really we crawl the history of each repository we encounter and store all the version of all files in there since the very first version. We also store all the revision metadata. So for instance, who is the author of a commit? What was the commit message? When was the commit done in terms of timestamps? If there are cryptographic signatures of releases, we store all of those, and also all crawling information. So essentially where and when we have archived any single element of source code among the above that we have stored in our archive. We do that in a data model which is canonical and independent from any specific VCS technology. So it's not like we only run some Git clones, but we crawl Git repository and store them in a common model. And we do the same for Subversion, for Mercurial, so that if 50 years from now, everyone migrates to a different technology, our data model will be the same, and we will not have to recrawl everything just because the world moved to a newfangled version control system. We currently do not archive other parts of classic open source projects like websites, wikis, issues, or mailing lists, because there are other initiatives that are taking care of archiving those stuff. So essentially, our plan is we focus on source code and its development history. We make it easy how to reference what we have archived, so that other places like some sort of semantic Wikipedia of software can reconstruct the history of individual open source projects, saying the source code is archived at Software Heritage, the mailing lists are archived at Gmail, and so on and so forth. In terms of data flow, we are essentially a big crawler. So we do not crawl the entire web, but essentially we have a curated list of places that we know distribute source code software. So software in source code form, sorry. So these are all the forges that you can mention: GitHub, various instances of GitLab, Bitbucket. You can have your own instances of self-hosted forges added there. We crawl distributions that also distribute source code, like these Debian source packages or package manager repositories like NPM or PyPy or CPAN. So we have all these places. We develop, as time goes by, essentially components that are able to visit those places and list all the packages or all the repositories that are stored there. And for each one of them, we create a data point, which is a software origin. So essentially a URL that identifies a place where source code is distributed from. And then periodically, we visit all those places, all those software origins, with a dedicated loader component, like a Git loader or a Mercurial loader or a loader for a Debian source package. And every time we crawl that software origin, we see what is the new software that is in there, and we store it in the archive. The archive has a peculiar data model itself, in which it is a giant graph, which is called a Merkle DAG. It's a structure that you might be familiar with if you have looked into ledger technology, or if you looked into the internals of modern distributed version control system like Git itself. And essentially, it is a structure that has some interesting properties in the sense that it duplicates everything. So essentially, in this structure, if you see the first time you see one file, you store it in your graph as a new leaf. But in the future, if you encounter the same file in a gazillion other different places, you just do not store it again. You just add a link to the file that you stored the first time. And this goes essentially all the way up. So the same entire directory of source code files is stored only once. The same commit, which we call revision in our data model, is also stored only once. So if you have 1 million repositories that all have the same commit, maybe because there are forks of the same project at a given point in its history, that commit is also stored only once. This is the same for releases, for software releases, and also for the entire state of a version control system repository, which we store in objects called snapshots. So a snapshot is like a picture that we take of a Git repository or of any kind of software repositories. And if that repository is forked thousands of times on GitHub, or even on different platforms like GitLab or any other forge out there, essentially we store the full state of the repository only once, avoiding wasting resources in storing it over and over again. And in addition to this structure, this Merkle structure, we have what we call software origins, which are just URLs pointing to the state of the repository that was found at that URL at the time of the last visit. So in a sense, what is interesting about this data structure is, on one side, the fact that we deduplicate everything, making it feasible to essentially do the archival work that we do, but also that we are materializing a unified view on the entire software commons. So we can see where software that you have developed yourself and published on your personal Git repository, maybe later on it's been used as a basis for doing something else in our research work or in some enterprise open source software. And we can see who has used your software if they base their work, their public work on it, and see that they've created a new version of it, for instance. This is just not theory, it's something that exists for real. So you can go to archive.softwareheritage.org and you will see there what are our current data sources. You will find that we crawl the most famous forges, we crawl many distributions, we crawl many package managers. We have there the archives of software repositories that no longer exist, software forges that no longer exist. For instance, we have a full copy of Google Code or Gitorious, or we have recently started archiving SourceForge, and also we have retrieved all the Mercurial repository from Bitbucket when they stopped supporting it. And all these are sources that you will find indexed at archive.softwareheritage.org. It is a pretty big archive, so we have more than 11 billion unique source code files archived, more than 2 billion unique commits archived, coming from more than 160 million projects. On disk, it's an archive of about 1 petabyte, so it is big, but it's not, big as on a video archive, for instance, but it's still substantial, not something you can easily host on your laptop. And if you're curious, if you're into graphs, it's also a pretty big graph. So it's 20 billion nodes and 200 billion edges. It's not as big as the graph of the web, but it's still a substantial graph. It is the largest public source archive in the world, and of course is growing daily as long as crawling goes on. So let me just show a few examples of how you can use it. So I'm going to share a different window here for a moment, just a sec. I'm going to share my browser window. And okay, so this is something that you can do yourself. So you can visit archive.softwareheritage.org today, and you will have a classic search box that by default searches on the URL of software origins. So this is a bit naive, but it's often used. It works pretty well in most cases because usually in the URL you have the organization name and you have the project name. So for instance, you can search HTTPD, Apache HTTPD, for instance, and you will end up on the what did I say? Oh, this is my network connection, I think. Yes. So Apache HTTPD, you will see here all the list of results. You will see that here the first hit is github.com Apache HTTPD. And if we click on it, you will essentially, what you will find is that essentially the equivalent of a repository browsing interface, but you're not browsing the live version of the archive. You're browsing a version of the Apache HTTPD archive on November 3rd, so a couple of 10 days ago. And if you go here on visits, you will see all the different archival runs we have done of the repository, starting from 2015 when we started archiving up on today. So you can browse into the directory as usual. So I'm not familiar with the source code of Apache myself. So, but at some point you can, for instance, let's go through the models. There's a caching model here, and at some point we will find some definition of code that comes directly from the Apache HTTPD source code base. You can do interesting stuff like you can reference individual files using our persistent identifier. So if you click here on permalinks, you will find essentially a link that you can copy. And this is an identifier that we always refer to this specific version of the file modcache.c. And you can share it with others. And that will allow anyone to retrieve this precise version of these source code files forever within the Software Heritage Archive. You can also do other stuff. So for instance, if you go back to the top bar, you have here a Save Again button. So for instance, here, this can be used to tell to our crawlers, can you please prioritize archiving again this repository so that the next crawl, it's not whenever the crawl have time for it, but will be like in the upcoming few hours. You can do that. You can also see all the branches and all the releases of this repository, okay? So here you have a bunch of, you can navigate through the branches. You can choose a different one as you would do in a generic version control system interface. Something else you can do is use this interface, which is save code now, which essentially, instead of just asking our crawlers to archive again something that has already been archived, you can ask the crawlers to archive a repository you care about. So there is for now support for Git, Mercurial, and Subversion. We are rolling out support for CVS soon, and there is also support not open to the public, but already available to staff for archiving individual tarbles and zip files that people might have on some institutional websites or their own page as well for demand archival of specific piece of code you care about. So back to the rest of my presentation. So this is essentially the experience you can have as a user. And in addition to that, if you are a developer, you might want to integrate with our API. So it's a RESTful API, which is essentially the equivalent of what I've shown you can do with the browser. So you can use the interface for searching for stuff that you have archived, and then for browsing them down. So you can see what are all the visits of a given repository, find the top level snapshot of them, and essentially go down to the revision, to the directory, to the file contents, and so on and so forth. You can also retrieve metadata for all the archived objects. For instance, we detect the license of files that we are archiving with Fossology. You can retrieve those metadata. And you can also have all crawling information like when have we last archived a repository you care about and where its branchings were pointing at the time. I'm not going to show you the detail of the API. They are fully documented on the web. Just click on Web API if you're a developer, and you will find all the details that you care about. Something else I've mentioned are these kind of intrinsic identifiers of all the stuff that we archive that you can obtain with the permalink button on the web interface. And these are actually becoming pretty popular identifiers in the ecosystem. For instance, if you care about software bill of materials of software that include free and open source software, there is a standard called SPDX, which is used among industry to share this kind of information. So which open source components are contained in this product I'm buying or putting on the market. And you can use software heritage identifiers in that kind of documents. If you go on Wikipedia, and you can also associate to software projects a property that points to their software repository, and you can use software identifiers there as well. It's also a IANA registered URI prefix. So essentially what we are expecting is that in the future, people will be able to just put those URI into their browser or any other application that uses IANA URI prefixes and get automatically pointed to the version of that piece of code archived on software heritage. So for instance, here in this slide, I have two links. I'm going to share the slide. So here there's a link that if I click on it, it's going to bring me directly to the famous implementation of the reverse square root in Quake 3. And it's just a SWH, 11, etc. Intrinsic identifier. And the same, this is a piece of code. This link will bring you to a piece of code of the Apollo 11 source code, which of course we have also archived. You can use those identifiers on your own code. Okay, so you can install a Python module that compute these identifiers for source code you care about with the pip install SWH model, and you can use it to compute the identifier software you have on your local machine. Okay, of course, as long as the software is only on your local machine, you will not be able necessarily to find it in the archive itself, unless someone else has archived it. But if you discover that software you care about is not archived yet in Software Heritage, you can use the save.softwareheritage.org interface, which I've shown you before, to request archival of the piece of code, so that in the future, everyone that care about your software will be able to find it on Software Heritage as well. And the last technical thing I want to show you today is that we also have a software heritage file system, which is a virtual file system built on top of Fuse, file system in user space that you can find on Linux, and that allows you to mount on your machine a piece of the software heritage archive as if it were locally available software. Okay, so it's the file system itself is of course implemented as open source software. Here you have links to the source code of its own implementation and its documentation, and we also have a paper describing it if you are interested in the software engineering aspect of it. But if not, let me just give you an example here. You can install pip install swh.fuse, which will install the Python module implementing the virtual file system. Then you will mount an empty directory that you just create for this occasion. So you create a directory, you mount it, and you will have in there a bunch of virtual directories from which you can start browsing the archive. For instance, imagine that you know that a file you care about have a specific software heritage identifier, like this one, maybe because you have found it on the web, or maybe because some paper or some other website was referencing code using software heritage identifier, maybe Wikipedia, for instance. And then you can simply do cat archive/identifier, and this will show you the content of this specific file, which is one of the many possible versions of a classic Hello World implemented in C. So this is just for a single file. Then, of course, you can do more. Imagine you have this directory identifier here. You can cd into that virtual directory. You will do ls. You will find that there are 127 files in there. And this piece of code is, in fact, the code of the Apollo 11 guidance computer that you can grab. So, for instance, you can grab antenna in a bunch of files, including this file, which I happen to know contains stuff about the antenna positioning. And you will find comments from the original Apollo 11 source code as if they were locally available on your machine. So this is without having to do any Git clone, any retrieval of tarball at all. It's all a virtual file system that operates over the network using the software heritage REST API. You can do more. You can, for instance, cd into a virtual directory for a commit. So this is a software heritage identifier of the rev type for revision. And you will see in there that you have a bunch of virtual directory containing the development history, such as the previous commits, or metadata. So metadata are in JSON format. So you can use, for instance, the command line tool JQ to retrieve the author name, date, and message of this commit you have retrieved here. And you will find that here is the author name. This is a timestamp of when the commit was done. And here you have a commit message. Or you can just do stuff like this. This is a specific commits of the jQuery project, I believe. So you can search all the JavaScript file contained in this source code version and count all the lines of code in there. And there are 10,000 lines of code in this specific version of the jQuery library. Last example, you can check all the branches that there are in a given project at the time of archival. So you can use SWH web search, which is the equivalent of the web search which I've shown you. Here we are searching for a project called GitAnnex, which is a great distributed and open source replacement for Dropbox and similar services by Joy Hass. You will find here the project, okay? And so essentially what you can do is that you can cd in the virtual directory corresponding to this project, and you will find that the last version, when this slide has been written, there are more recent archival now, but at the time there was only a single visit taken on December 2020. And you can see where the master branch was pointing at the time that snapshot was taken. This was it for my general presentation. So let me just tell you something about how you can help, and then I will be happy to answer your questions. So you can help, first of all, as a user by expanding archive coverage. If you find something which is not something you care about, some piece of free and open source software you care about that is not archived yet in Software Heritage, just go to save.softwareheritage.org, or just click on Save Code Now on the archive web UI, and ask our crawler to archive that piece of code. That is very important, and it's a simple step that everyone can do. You can help financially. So we are a non-profit initiative, as mentioned. We accept both donations from individual and sponsoring for companies or institutions. So if you want to be a champion for a new sponsor, that's very much appreciated. You can help as a coder if you are into development by just joining our community of open source developers. So you have all the classic information like where is the code, where is the chat, where is the mailing list, where are the bugs, and so on and so forth. It's all available on the website on the developer community page. Or you can also, take the next step and consider working with us. We have opportunities for both students as internships, both practical and more research-oriented internships. And we also have job openings for both technical and management level profiles. So anything you can do to help with our mission would be much appreciated by us and also by future generations. So thanks a lot for listening, and I'm available to answer all your questions.
Thank you, Stefano. I actually have a question for you. Thinking the equivalent of sorry, let me try to, I don't know what is happening, sorry. Okay. Hi. I was wondering, as you gave this presentation, how could such a large corpus of information be classified? So the equivalent of a large library is that there's a taxonomy system that says, for example, there's the standards of the Library of Congress in the US, that there are different subjects like medicine, astronomy, philosophy, and so on. So I was wondering, what could the equivalent be for software?
Right. So essentially, this is the question about metadata, essentially. And there are several standards about software metadata. We are working with a lot of digital librarians and people developing ontologies for software. And there are several ways to do that. The way we are attacking this problem right now is that we are mining separately from archival. We have essentially an asynchronous process that periodically is do mining of all the software metadata that are contained in software itself. And essentially, we are exhibiting it as an ontology of all the software we have archived. So I haven't shown you, but if you go on the search page, you have a button which says search in metadata instead of searching in the software URL. And you can search software using that ontology. Essentially, this is the first step we're doing right now, allowing users to find software on the base of the metadata declared by software authors. But of course, there is also the matter of how you cross-reference what we archive with people that are curating the history of software. And on that front, we're working, for instance, with the Wikidata folks to create links from Wikidata resources about software and the archive, helping essentially with collective curation of all the software we archive.
Great, so I will now head to the audience, and I would like to ask you if there are any questions you would like to ask to Stefano. Yes, please, could you please approach this microphone here so people online can also hear your question?
Hi, I'm Gianluca Boiano, and I want to ask the main concerns about binary object storage against versus the source code, because I've seen that in introduction the main topic is source code archivement. So what are the main concerns about a binary object? And I have another question. I don't know if I can follow with. Yeah, maybe. Yeah.
Answer.
Thank you.
Yeah. So about that one, very quickly. So we have taken a first decision early on in the project of not trying ourselves to exclude anything from the stuff we're archiving. So essentially, we decide that a place is primarily used to distribute source code. If that place also happens to include binary files, we also archive those at the moment. So for instance, on GitHub, you can find many repositories that people are using, let's say, not really properly, in also storing binary files in there. For now, we are also archiving those. It has not been a major problem right now, but that means that in the archive, you will find also incidental binary files, which is not creating a major problem for now at the moment. Okay. So maybe that leaves time for your second question.
Okay, thank you. The other question is about the previews that we have seen, the trial of GitHub for example, to archive on Arctic Code Vault, to archive the history of code and all the main contributions. So they stored the source code on microfilm made by a Swedish company. So what are the limits to storage and archive source code on, I don't know, a hard disk or digital proven, yeah. What are the main concerns?
We are part of the archival program of GitHub. We are in partnership with them, and in fact, what they stored under ICE, to simplify, was only a very limited subset of GitHub. For instance, they only stored projects with a given number of stars. They only stored projects that were active at the time, and they only stored the most recent version of each project at the time of their archival, because that technology is really expensive. However, it is important to have also archives that are offline, that are not stored on hard disk, as you say. And the way we are attacking this problem is that periodically, once per year, we want to take essentially offline copies on the entire archive and store them on technology that we cannot delete and that would resist the hypothetical electromagnetic storm of planetary dimensions. We're doing that for now in collaboration with CNES, which is a large digital archive institution here in France. But any sort of offline archival that can be taken periodically of everything we have, it's really important, and it's part of our mission.
Thank you, Stefano, and I hope next year you might be able to also join the SFSCon in person. And now I'd like to take the time to thank all of you for joining the sustainability track from the FSFE and for coming to the SFSCon. Thank you.